Okay, this is the Limpopo Physics Paper 1 trial exam from 2021. It's question 9 on electrodynamics. It says an engineer has an electrical drill which operates from an alternating current supply. The drill is rated as follows: 240 volts, that little symbol in the box is the AC symbol, 1800 watts and 50 hertz. It says the current passing through the drill when operating is represented in the graph below. And here you see we have this lovely sine curve. The lovely sine curve is one full wave, which we should know from waves, light and sound that this is a full wave. And they are showing you a reading on the graph over here of 10,6 amps, and down below it's minus 10,6 amps, which is the peak current for this power supply. Okay, or the current passing through the drill, not the power supply, sorry. It says to you, define the term root mean square RMS for an alternating current. Now, if you have the 2021 exam guidelines, you'll find it's much easier to do this. They used to split the definition. You had to split it on your own between current and voltage. Now it's got two definitions that you have to learn with the current and the voltage words swapped. So it says the RMS value of alternating current is the alternating current which dissipates the same amount of energy as direct current. So remember that alternating current has all of these minimums and maximums, and all of these minimums and maximums make a difference to how much energy is dissipated. And so when you average it out, the RMS value of AC, the root mean square value, makes the same amount of energy as DC. Now it says to you, calculated the time x indicated on the graph. So now if you have a look at this graph, the graph goes up and it stops over here. So the time x is exactly half of a wave, okay? Alternating current has the sine wave sign for a reason, because as you turn the thing in the magnetic field, this is what happens to the value of the current. It goes up and down. So this thing is telling you it is half of a wave. So if you know your definitions, the time taken for one full wave to pass a point, t, is called the period, okay? So this thing marked on the wave is half of a full wave, so it is a half of the period. And we know that there is a formula that links the period and the frequency, t equals 1 over f. So in the question here, it tells you that this is a 50 hertz drill, which means that there are 50 cycles of current per second. So the period of this wave is 0,02. That is a half of 0,02 is going to be x. So x is going to be 0,01 seconds. That is how long it takes for the time to point x, half a wave. Now it says to you, calculate the root mean square current the drill draws when operating. You know that anytime you use alternating current, you have to use the alternating current formulas. So you have to copy it exactly off the data sheet. So I root mean square equals I max over root 2, because remember, if we average out the current, we will end up with 0. So we have to use the root mean square to get anything sensible out of it. If we read off the graph, the maximum current, it's indicated over here, it is 10.6. If we divide by root 2, 10.6 over root 2 gives you 7,495, which you can round off to 7,50, and it's the current, so we are going to put it in amps. Then it says to you, what is the resistance of the drill? If we're going to find the resistance of the drill, we have to use this power rating that is given in the question. And so I like to use the power rating and the current off the graph. So I'm going to use this formula here, that P average is equal to I squared, or I RMS squared, times R. Remember, if you do not write out the correct formula that is on the data sheet, you will not get the marks. If you just go P equals I squared R from the normal current things, you will not get the marks. So you have to go and do this exactly like this, as it is on the alternating current on the data sheet. Okay, so if you then work this out by algebra, 1800 by 700, 7,495 squared. If you've used 7,495, you will get 32,04 ohms. If you've just used 7,50, you will get exactly 32 ohms as the resistance of the drill. You can also work it out using the voltage, but I prefer to work it out using the current off the graph. Now it says to you, explain why the transmission of the electrical energy is carried out using alternating currents and high voltages. And so from a scientific point of view, with alternating current, you can step up and down the voltage and the current using those transformers. Remember, they always show you those pictures of the transformers like this with a soft iron core, and then there's a massive coil on one side and a small coil on the other side. So this one is a step down, but if you reverse it, it becomes a step up transformer. So this is the main reason from a scientific point of view. And from an economic point of view, what happens is if you make the voltage extremely high, remember the voltage and the current are like inversely proportional to each other for a fixed resistance. So what happens is when the voltage goes up, the current goes down, and the current is what causes the heating effect. Remember I squared R. So from an economic point of view, you do not lose heat or energy, because remember, you're selling this electrical energy. You don't want to waste any of it. So the energy loss by the transmission cables is minimized by high voltage transmission. So they step up the current, it goes to a massive voltage, no energy is lost in transporting it across the country, and you can make more money.